Hi, I recently created a new augmented reality experience showing the periodic table in augmented reality space. A few people wondered how I did it, so I thought I would just walk through the code if that's okay. Now the effect that we're looking at is this one that's directly behind me. As you can see, each of the 118 elements, I think, is just floating in space, and then you can take your camera and walk around them. So to do that, what I did was I treated all of that table as a number of rows and columns, like many tables. So you can see hydrogen is there in row 1 and column 1, and then on the 8th row, I'm just treating that as a blank row, and then continuing with rows 9 and 10, and number of columns go all the way from 1 all the way through up to 18, and that allows me to plot each of those elements, give them an x and y coordinate. That's what I did. Okay, so this is the effect we're after, and you can see in this one up here, this was version 1, and that was very plain. The elements were just there. You got this transparency effect, which is always nice in AR experiences, and you can just walk around it. Now in this one, it's gone weird. It's a bit more evolved, so you can select the items and they'll change color, and then the Z index it'll move towards you, but also they don't all appear at once. They all appear at a random time and fade in as well. So that's what the code we're going to look at next. Right, so here's the code. This isn't going to be the best code in the world, by the way. This is just a proof of concept, just put together to just see if I could do it. So please, please, please don't add comments in the code saying this method could be shorter, this collection is inefficient, stuff like that. If you want to rewrite it, fine, do that. I just don't need to know about it. Okay, so I have minimized a few of the methods that are a bit of boilerplate, and so we won't need to look at those. So I've got some variables up at the top here. I don't actually use that one. I thought I might, but I don't actually use that one. That's elements, there's 118 of them. Columns and rows, I definitely use 18 columns and 10 rows. Now width is going to be the width of each element on that table, and I've set it's 0.1, which is a float, and that is effectively 10 centimeters, because in ARKit, a value of 1f is 1 meter. So they're going to be 10 centimeters high, 10 centimeters wide, with a margin of 2 centimeters in between them. Okay, so if we come into the view did appear event, which is again bog standard, the only thing that I'm adding starts here. So first of all, I'm getting my elements, collection of elements, and I will go and show you what's happening there. I have an element class. It has an atomic number, a name, a symbol, row and column. Then I've got a constructor that I set all those variables with. Then I've got a static method which gets them all, and it took me ages to type this out. Really did. So I say what rows and columns each of these are in, and it's pretty simple. That times 118. Okay, so that's that collection. Next thing I'm doing is creating a new root node. So I could add each of these elements directly into the scene, but what I'm doing is creating a parent one and adding them all to that parent one. And the reason I'm doing that, as you'll see later, is that I then want to move all of them in one go. I didn't want to move them all individually. You'll see. Right, so that's this periodic table node, this parent node I was talking about, rambling about. Then I've got this an instance of random, because I'm going to do some random stuff, random duration. Then I iterate for each of the 118 elements, and I calculate the x and y coordinate by taking the column and multiplying it by the width and the margin. And I do the same for the row, and that tells me roughly where it's going to appear vertically and horizontally. And then Z is sort of forwards and backwards. So I'm saying start them 1.1 meters away from me. The reason I do that is I'm actually going to animate them towards me a bit. So I'm going to start them quite far and then animate them towards me. Okay, so this is I'm creating using a new class that I've created called Element Node. Let's go have a look at that. So this inherits from Scene Node. So every node is going to, in ARKit, inherits from that, which allows you to set it, give it a visibility and a geometry. Okay, so I'm setting the actual elements class that we talked about earlier. Not actually using that can come out. Then I've got a boolean which says whether the element is selected or not, which I'll use later. Then I've got the constructor for it, where when I pass in these variables, I'm setting the element, and this is where it starts getting interesting, in my opinion. And what we're doing is we are setting a default material, and we are saying just make it green. And see, this is from my first iteration. That's not actually going to do anything. That was before I started using these Skier Sharp images. So that was just when I was using green. So that's actually not being used, that one. Although I am using the double-sided. I'll explain in a minute. Right, so the position, I'm setting it there, which we calculated earlier from the constructor. Then I'm creating this plane. And now ARKit has a number of default geometry shapes you can use. We've got cubes, cylinders, spheres, donuts, pyramids, cones, all sorts. The one I use the most is a plane, which is just like a flat, two-dimensional square. So that's what we're doing here, and we're saying set its width and height, and we're setting its materials to be this, which up here is green, but I immediately override that. Again, the code's not the best. So what I'm doing here is I'm getting an image, and I'm using Skier Sharp, and then once I've got the image, I'm setting that as the material. Probably wouldn't write it this way. Anyway, more about this getting this image. So what I'm doing is I'm using Skier Sharp, which is a NuGet package and a bit of a graphics library you can use, which plays very well with Xamarin, it would appear. And so I'm creating a surface, arbitrary numbers, because as long as it's square, I guess, because it's just going to shrink down to fit the plane anyway. 400 wide and 400 high. Don't know what these are. Then I'm getting the canvas, and I'm clearing the canvas with the color. And remember, it's this color here, so it's a dark cyan to begin with, which is like a rubbish green. And then I'm saying with alpha, and that means give it some transparency. So I forget what that goes up to. Is it 256? I don't know. It's transparent anyway. Then what I'm doing is I'm saying on this Skier Sharp image, I want to add the symbol. So I'm creating this rectangle of where the it's going to go. Yes. I'm going to say, and these are dimensions of the rectangle from the top and the right. So I do that a bunch of times with the symbol, for the name, and for the atomic number as well. And then I draw those text blocks onto the image, and then I return the image as a format that Xamarin can actually use, which is this UI image, which is an extension method, which is really cool from that package, I believe. Right, so that's the element node. Not too much complicated in there. You might have just caught sight of a oh no, thinking of something else. Ignore me. Right, okay, so we have at this point created the element nodes. The next thing we're going to do is set the opacity to be 0. So I want it to be completely invisible to begin with, because I'm then going to animate that opacity to 1 i.e. make it opaque, to give it a nice animation. So this is this animation, this duration here is how long I want to wait before starting that fade in animation, because I don't want them all to appear at the same time. So it's decides a duration between 0 and 10 seconds. So that's the wait action, and these scene actions are how you do animations in, well, it's one way of doing animations in ARKit. And another action or animation I'm doing here is one for the opacity. So I'm saying fade in, and that says just take whatever the opacity value is and then change it to 1 over a period of time. So I'm saying a period of half a second, change it from whatever opacity it is all the way up to 1. So it's fading it in. Then I've got another action here, which is a move to action. So I'm saying here, move the move the node over 5 seconds, and the only thing I'm changing is the Z index, really. So like I said, I started with minus 1.1 meters away from me, and I'm going to be coming forward, so it's just 0.9 meters away from me. So that's that Z action. And then what I'm doing is I'm combining these actions so they happen either at the same time or one after the other, and I'll explain. So you can group actions, and that means it'll do them both at the same time. So it's going to do the opacity action and the move Z action at the same time. So that's one action. And then and then this other action, what I'm doing is saying I want you to wait and then fade. Okay, so this is sequence that you can do as well. So it takes again an array of actions, but this time it's saying I want you to wait for that period of time and then fade and move in. It's hard to explain, but it kind of works. And then what I'm doing is I'm setting the timing mode for this animation to be ease in and ease out. So by default, it's I believe linear. So if you think about animation, not much in reality sort of starts and stops straight away. So if you get in your car, you don't go to 30 miles an hour instantly. You sort of accelerate, and then when you come to a stop, you sort of slow down. You don't just stop. You'd go through the windshield or hurt yourself on your seatbelt. But and it's one of the laws of animation, I believe, from Walt Disney, says you should ease things and ease out, because with animation you want to mimic what happens in the real world. And nothing just appears or suddenly goes from 0 to 100 miles an hour. Even a bullet, imagine, I'm digressing a bit, but even a bullet, I imagine, is a small amount of acceleration. What am I going on about? Right, okay, so then I run this wait and fade action. Then, and then I add this element node to the periodic table node, and that's got all of them, as you can imagine, in different positions. Now, this is the reason I use this periodic table node is, by default, when you start the camera, where you are is 0, 0, 0, 0. So everything that I plot, X and Y, will be off X and Y over here. Okay, and so what I'm doing is I'm kind of setting a new X and Y position for the whole table. So I'm calculating it roughly, I think I've missed the margin off, but roughly half the table's width and half its height, and kind of shifting it back into the middle of the viewpoint, if that makes sense. Yeah, possibly doesn't. Okay, so I'm adding the periodic table node to the root node of the scene. Okay. Now, so that's it for adding them. You might wonder, and the animation, and you might wonder how the touch effect is achieved. So there's different ways of doing this. This is the basic, easiest way. So I'm actually hooking into the touches ended event, and what I'm doing, I'm saying if there's been a UI touch event, I think, get the point, and then and then it's saying has any elements or any AR nodes sort of been touched in underneath where you've clicked on the screen, and then it gets the first one, and if it's not null, it gets the node, and yeah, it gets the node. And then what I'm doing is I'm sort of casting that node into the element node because I know it's an element node. I've not put any other nodes in there, although I did put the table node in. Anyway, and then it casts that to element node, and then runs this method on it called toggle selection. So let's go see what that does. So what toggle selection does, it first of all, it toggles the is selected. So by default, is selected will be false, and it will change it to be true. Okay, so these nodes all maintain their own state in the scene, by the way. So as soon as I toggle this, it's going to remember it in there. Then I've got a UI image variable because I'm going to create a brand new image for the node. If it had a green image, I'm going to create the red image equivalent. If it was a red image, I'm going to create the green one. And then I've got this move Z action, which is the new animation I'm going to do. So if it's not selected, I'm going to change it to red and move it forward. And if it is selected, I'm going to change it to green and move it back. Which is exactly what I'm doing. If it's selected, change it to red. We looked at this getImage method earlier, and then move it to its new position. Those positions don't look quite right, but never mind. The video and the effects look okay. And I'm doing that over half second. Yes. So then once I've got the new image, I'm getting the nodes, changing the geometry of the nodes, first material to be that image, and then I'm running that Z index action. And that is all the code for the periodic table. Most of it is taken up by the big collection of elements, of which there are many, and it took me ages to type it. So yeah, it doesn't do much. It could do a lot more. But it's satisfied my curiosity building it, and hopefully if someone wants to build it or make it better, they can do. So yeah, that is the code. I hope you've enjoyed that. That's been Augmented Reality Periodic Table proof of concept. If you enjoyed that, follow me on YouTube or follow me on Twitter. I'm on both. I'm on LinkedIn. And I hope to be doing some live Twitch, actually coding this sort of stuff live. God help me. So until next time, catch you then. Thank you. Bye.